Hi. Okay, we're trying to figure out why are we limiting the size of groups that we can get together in. If you remember in chapter 6, we did the at least one problem. That's actually what's going on here. So there's a little spreadsheet I made for myself just because I'm a numbers guy. I like to see what's going on. So, um, we don't know the probability of each person having the virus. So this is a variable in my spreadsheet. I could put in any number I want. So I just said, how about 1% of the people have the virus? Think it's too high? Then put in a lower number. Um, Scary part is what if it's too low? Well, then things are going to be worse than what this model says. Okay, so what if we say the size of the ring, that's n, let's call that 15. Well, first of all, we know that if 1% of the people have the virus, 99% don't, again, it's 1 minus, or 100% minus the 1% is 99%. All right, so what we ideally want is we go into a situation where no one at the gathering has the virus. So that would be the percent here. Again, I just bring it down here, 99. So it's decimal point 99 raised to the 15th power, because that would say all 15. The first does not have it, the second, and the third, and the fourth, and we multiply those all out, and we get an answer of 0.860058. So probability that no one in the group of 15 has a virus is about 86%. All right, well then what's the probability that at least one person in that group of 15 has the virus? Well, it's everything except the situation where no one has it. So it's 1 minus probability of none. Probability none there. So we get this number here. So then just written as a percent, like, oh, a little under, well, almost exactly 14%, 13.99%. All right, well, that's not too bad. Let's talk about the beaches in Florida before they're closed down. I don't know. How many people did you see in close proximity on those beaches? Let's say 100. Okay. Now we're up to 63% probability. Unfortunately, this seems to be what's going on. There's already reports of these students flying home and carrying the virus with them and getting sick. And then what happens there? Probably their parents or friends, their roommates, they get them infected, and we've got another hotspot, and it keeps spreading all over the place. So originally, the government said, how about 250? Oh my gosh, 250. Why don't we have situations where everybody can get together and watch sports or hang out at big bars and all? Wow, look at that, 92%. And again, I really don't think this number is accurate anymore. A while ago we were under 1%, but I don't know if that's true anymore. I will do that in another video. I think I'm going to post this spreadsheet for you. If you want to play with it, feel free, because again, I don't know the probability, but it's like, could be any. But here's the last thing I want to leave you with. Let's go back to 1% of the people have of the population have the virus, and we're talking about 20 people. There's nothing in the math that says those 20 people have to be together. So you go to the grocery store and you bump into 20 people, one at a time. Now, once again, if you're practicing real safety measures, it's going to reduce the chances of you getting the virus, but the chance that someone in that store or on your trip has the virus, if it's 1%, you still have an 18% probability of coming in contact with someone with the virus. So that's why it's very important to minimize contact with other people. It's tough, it's not fun at all. going stir crazy, but we've got to flatten the curve. We've got to slow down the growth. Once again, if you're wondering about growth, which is exponential, that will be in another video I do. So thanks for your listening, and best of luck to you. Keep calm and carry on at home.